let's do the integral for secant cubed x dx. So there are different methods to do this, but let's use uv integration. So we have u dv equals uv minus integral of v du. So what should be our u? Something with the easy derivative. Let's choose secant x. So that du equals secant x tangent x. For our dv, something with the easy antiderivative, we have secant squared x dx. So that means our dv, and my v's look like u's, our v will be tangent x. So when we write this out, we get, let's write it up here, we get secant x tangent x minus the integral of v du, so tangent x times secant x, and then there's another tangent here, so let's square this tangent, d, and this is supposed to be dx, so dx. So let's write tangent squared x in terms of secant. So we have secant x tangent x minus integral. What is tangent squared x in terms of secant? Well, if we know our identities, we know that it's secant squared x minus 1. So secant squared x minus 1 secant x dx. So write that out, and let's distribute and then let's distribute that negative sign there, and then let's make these into two integrals. So the first one is secant cubed x dx, and then these two minuses make plus integral secant x dx. Now, there's something very interesting we could do here. We know all of this obviously equals our integral of secant cubed x dx. So then if we have a secant cubed x here, if we add it to both sides, what we get is this. Two secant cubed x dx. Let's divide 2 from both sides. It's going to equal, obviously, just the integral. Now, all we have to do is the integral for secant. So let's do it. How do we do this? Now, there's one easy way. Let's actually not do this. So let's multiply both sides by tangent x plus secant x. This is one of the easiest ways to do this. It's still good to know multiple methods though, but this is one of the easiest ways. So if our u is tangent x plus secant x, what's our du? Well, it's going to be secant squared x plus secant x tangent x dx. So let's look back at this integral. Let's actually distribute this. So we have secant x tangent x plus secant squared x. It's the same as this. And then on our bottom, we have secant x plus tangent x. And then dx. So we could put this in for you there. And so you can make this top here is actually equal to du. So do du, and then the bottom is just u. So pretty easy integral. We know this natural log of secant, well, no, it's a natural, let's scrap that. We know that this is the natural log of u. I'm getting ahead of myself. Plus c, which u equals, for here, this u, tangent x plus secant x. So natural log of tangent x plus secant x plus c. Now, if we put this back into our equation here, what we get is 1/2 secant x tangent x plus natural log of tangent x plus secant x, all plus c. Plus c. Now, there's another interesting way to do integral of secant x dx. And this may be useful, this thought process may be useful for other integrals. So if we have a triangle, and let's say we have this angle equal to x, and let's make u equal to secant x. So it's u over 1. So if we look at this triangle, what is secant? It's hypotenuse over adjacent. So hypotenuse is u, adjacent is 1, and what's this side? Well, 1 squared plus whatever that side is squared. If you can see that. 1 squared plus whatever that side is squared equals u squared. So we know that this side must be equal to u squared minus 1. So this is u squared minus 1. So now what we can do is take this integral and we can put this in for u, right? But we need a du, of course. So du equals secant x tangent x dx. So that means this here will be u, and then we'll have 1 over secant x tangent x du. If we divide secant tangent for both sides, then we get what dx equals. So we know secant x is u, so integral of u over u tangent x du, cancel those out, and then we just have 1 over tangent x du. So what is tangent x? If we look back to our triangle, what's tangent? Opposite over adjacent. So we'll have the square root of u squared minus 1 over 1, but it's on the bottom, so let's take the reciprocal. So we have 1 for square root of u squared minus 1 integral du. Now, if we remember our inverse hyperbolic trig functions, we'd know that just this expression here, just the expression 1 over square root of u squared minus 1 is the derivative of the inverse hyperbolic cosine. It's the derivative of this. So if we're taking an integral, we're going to get the opposite. We're going to go backwards. So we know that this must equal hyperbolic cosine inverse. So inverse hyperbolic cosine plus c, which also equals, so inverse hyperbolic cosine secant x plus c. So that's another way to do it.